Hello, good morning to all of you. I hope all of you are doing well. So in today's class, we're going to discuss CoCoMo model. Now, CoCoMo basically stands for Constructive Cost Estimation Model, and it's one of the widely used algorithmic model for computing effort required for completing a project. Now, CoCoMo model was proposed and developed by Barry Boehm in the year 1981, and one of the fundamental equations of CoCoMo model is the effort equation that tries to equate effort required for completing a particular project to a parameter that is known as person month or staff month. Now, for estimating effort, it takes into account a parameter that is known as KDSI, which stands for thousands of delivered source instruction. Now, CoCoMo model is best suited for application fairly late in the development life cycle, typically during design phase, when you have a rough estimate about the problem size in terms of kilo source lines of code or KDSI. Now, this is one of the major drawbacks of CoCoMo model because cost and effort estimates are required typically early in the life cycle phase, that is during the requirement analysis and specification phase. Now, CoCoMo model basically tries to categorize each and every project into three identifiable categories, and these categories are called as developmental modes. Now, there are namely three developmental modes. The modes are organic mode, semi-detached, and embedded mode. Now, a project qualifies to be an organic project if the project is being developed in a familiar and a stable environment, and you have an experience of developing similar project from the past. Again, I'll repeat it. A project qualifies to be an organic project if the project is being developed in a familiar and a stable environment, and you have a relative experience of developing similar project from the past. Now, likewise, a project qualifies to be a semi-detached project if it has characteristics somewhere in between organic and embedded. Now, likewise, a project qualifies to be an embedded project if it requires a degree of innovation and there is and it's subjected to tight, inflexible interface requirements and there are imposed constraints. So these are the qualities of organic mode, semi-detached, and embedded mode. Now, there are three basic types of CoCoMo model. The CoCoMo models are known as basic CoCoMo model, intermediate CoCoMo model, and detailed CoCoMo model. Now again, I'll repeat it. There are three types of CoCoMo model, namely which are basic CoCoMo model, intermediate CoCoMo model, and detailed CoCoMo model. So now in case of basic CoCoMo model, now basic CoCoMo model is a single variable model. That means here what we have one independent and one dependent parameter. Again, I'll repeat it. Basic CoCoMo model is a single variable model where we have one dependent parameter and one independent parameter. Now, there are two proposals that are being made by basic CoCoMo model. These are in forms of the effort equation and the schedule equation. Now, the effort equation in case of basic CoCoMo model takes the following form. The effort equation is equals to A1 into KDSI to the power B1. So again, I'll repeat it. Effort is equals to A1 into KDSI to the power B1, where A1 and B1 are constants. Okay, where A1 and B1 are constants and have different values for the three developmental modes. So for organic, effort equation is as 2.4 into KDSI to the power 1.05. For semi-detached, the effort equation is as 3.0 into KDSI to the power 1.12, and for embedded the effort equation is as 3.6 into KDSI to the power 1.20. So just see here what we have is we have different values for A1 and different values for B1. So different values for A1 and different values for B1 represents the various developmental modes. Now likewise, the schedule equation for basic CoCoMo model takes the form as TDEV. So TDEV stands for T developmental time. That is developmental time is equals to 2.5 into effort that was previously estimated into 0.38. Likewise, T developmental in case of semi-detached is equals to 2.5 into effort to the power 0.35. Likewise, in case of embedded, development time is equals to 2.5 into effort to the power 0.32. So just see here what we have is we have different values for A1 and A2 and B1, A1 and B1 and A2 and B2 for organic, semi-detached and embedded. Now the unit for representing effort is called as person month or staff month, whereas the unit for representing schedule is in months. So unit is in staff month or person month in case of basic effort equation, and it's in months in case of schedule. Now likewise in case of intermediate CoCoMo model, what we have is, just see, the intermediate CoCoMo model basically tries to refine the accuracy of the basic CoCoMo model, because basic CoCoMo model does not take into account differences in hardware, personal quality, experience, use of modern tool and other project attributes, which is known to have significant influence on the project. So Barry Boehm in the year 1997 proposed intermediate CoCoMo model that tries to refine basic CoCoMo model, take into account various environmental factors. Now, how these environmental factors are taken into account is by estimating a factor that is known as effort adjustment factor. So, effort adjustment factor takes into account 14 effort multipliers and their influence on the project development. So here, in case of intermediate CoCoMo model, the effort equation takes the form as effort is equals to EAF into 3.2 into KDSI to the power 1.05 for organic. For semi-detached, effort is equals to EAF into 3.0 into KDSI to the power 1.12, and embedded effort is equals to effort is a factor into 2.8 into KDSI to the power 1.20, right? So here just see, here what we have is we have introduced an cost multiplier that is known as effort adjustment factor, and the effort adjustment factor is estimated taking into consideration 14 effort multipliers. Each of these 14 effort multipliers are represented in a 6-point scale based on their influence. Okay, again I'll repeat it. Each of these 14 cost multipliers or effort multipliers are represented in a 6-point scale based on their influence. Okay. And eventually, after selecting the appropriate values based on the influence, the product of the 14 cost multipliers or effort multiplier forms the EAF. So EAF is the product of 14 effort multipliers. Now, if all the 14 effort multiplier has a nominal influence, that is, if they are all assigned values 1, then the effort equation will look similar to that of the basic CoCoMo model. So that is the major distinction between the effort estimation in case of basic CoCoMo model and intermediate CoCoMo model. Intermediate CoCoMo model refines the basic CoCoMo model, taking into account the additional 14 effort multipliers and estimating effort adjustment factor and introducing it into the effort equation. Now, as per the schedule equation, the schedule equation will be same as that of basic CoCoMo model, because the influence of the cost multipliers or effort multipliers has already been considered. So the schedule equation for intermediate CoCoMo model will be same as that of schedule equation for basic CoCoMo model. Now, detailed CoCoMo model. Now, as we have already discussed, detailed CoCoMo model takes into account a situation where what we have is we have because till now what we have done, what we have considered in case of basic CoCoMo model and intermediate CoCoMo model is that in case of basic CoCoMo model or intermediate CoCoMo model, the entire project is either basic considered to be semi-detached, or it is considered to be embedded, or it's considered to be organic. But in situations there might be that particular aspect may not be true. Let us consider as an example different phases in the software life cycle. Different phases in the software life cycle may be one of the phase may be organic in nature, the other phase may be semi-detached in nature, the third phase may be embedded in nature, because different phases may have different nature and different orientation. So in order to overcome that particular problem, the detailed CoCoMo model was proposed. The detailed CoCoMo model tries to assume that the different phases in the software development may be pertaining to different developmental modes. So what we need to do is we need to use different effort equation and different time equation for estimating the various effort required and the time required for executing different phases. So that is the property of detailed CoCoMo model. So detailed CoCoMo model takes into account the varying nature of the different phases in the software development life cycle, and then tries to correlate it to whether it's semi-detached, organic, or embedded in nature, and then tries to create an estimate about the effort and the cost. So that is the property of the detailed CoCoMo model. So in today's class, what we have learned about is we have learned about what is CoCoMo model. We have learned about what are the different developmental modes in case of CoCoMo model, and we have learned about in basic CoCoMo model the effort equation and the time equation in case of basic CoCoMo model. Then we've learned about intermediate CoCoMo model and the refinement and the way how the intermediate CoCoMo model refines the basic CoCoMo model, taking into account the 14 effort multipliers and refines the effort equation. And we have learned about detailed CoCoMo model, that is advancement on both basic and intermediate CoCoMo model, that tries to impose different developmental mode with the different phases that are there in the developmental life cycle, and then tries to create an estimate about the effort and the time required for executing the different phases. So as we moved on from basic, intermediate to detailed CoCoMo model, we have moved on with the refinement on the effort equation and the time equation. So this ends the today's class. So thank you very much.